Hello, welcome to the tutorial to predict energy budget of a building for a month, and we will have the data of the weather for 3 years. We also have the data of energy consumption for the same period. To predict the budget, we have the energy cost for a month, and here we will use Python coding in using Google Colab, that is colab.research.google.com, where we can log in with our Google account like me, and we can connect our Google Drive here, and from the drive we can bring all the related documents that we will use to predict the energy consumption. To keep the video short, I have written the codes beforehand, but we will go through each line what is happening there, and I will try to cover up some theoretical background regarding my considerations, then why we are considering what. So let's start with the importing related library that we are going to use for this prediction task. At first we import pandas library for data analysis and manipulation, and then we will import numpy, which is for large multidimensional arrays and matrices, and then we will import matplotlib for data visualization. And to run the cells, we either click here or we press shift enter to run the cell. So after importing the libraries, we will load the data, and for this we use the pandas library, and it is imported as PD, like numpy as np, and so later we will use only this small version. So for this we put a name for the variable energy1, that is pd.read excel, because it is an Excel file, and we follow this path. From where it is importing, we have to copy the Colab notebooks, and then in this folder I have all the related documents. From here we can copy path and paste here, and accordingly we can run the cell. And when we run the cell, it is imported, and we see the data how it looks. It's more than 26,000 rows and 2 columns. You see the row indexes, it starts from 0, so it ends also 1 less from the total. So for data manipulation and processing, we need this time column as an index, so that and that will help us to analyze. And then we change the name of the variable, and we put it at a set index function and the name of the column. Please remember it is the capital letter, because it is case sensitive. And then when we run this, we see the index column is gone and is replaced by the time column, and the number of column also reduced by 1. And we can have a look with the describe function how it is distributed. The mean value is 26, and the minimum value and the maximum value is 60, but mostly it is distributed within this. We can visualize this distribution with a box plot like matplotlib, which is plt.boxplot, and energy with the name of the column that we want to show. And we can also use this kind of column with other kind of commands like location, that is this is the row and this is the column. So when we use this, that means we want all the rows of this column. And we can also use the location of the column with the index. In that case we use index of location. So with the plt.show, we bring this box plot, and we see how it is mostly within between 20 to 30. There are other libraries also which can show us box plots like Seaborn, and we import the Seaborn as SNS, and is the same way we call the box plot like we did in matplotlib. Well, then we load the weather data. It is the same way from the Google Drive. We copy the path and we paste it here, and we read Excel with the path for the path, and we bring the variable KNMI with the same period, so same number of rows are here, but there are 12 columns for month, day, hours, temperature, relative humidity, and so on. So we again put the time as index. So now you see the number of columns reduced by 1, and then we concatenate the energy column with the weather data. So with axis within this bracket, we define it is a column, so it adds on the end to the right. Otherwise, if we put axis equals to 0, then it is rows, so that this data frame rows will be added underneath the rows of the previous data frame. Well, so we define this as a data frame after the concatenation. So then we check if there is any missing data, as we see here, like is NA is not available data, and sum is the total, that every columns are checked, and we see there are no missing data. We can also check the availability of the data from the library missing no as MSNO, and in the bar graph you see all the columns have the same number of data. Now let's see the correlation, and in Python we can use this .core method, which we can utilize Pearson's correlation coefficient, which is a measure of the strength of linear association between two variables. That means if for the energy consumption, like the building energy demand, which variable is the mostly correlated, and also in between these variables which ones are interrelated. So to run this, at first in this code of line we create the matplotlib figure, and plt.figure we use this figure size. If we increase, it will be wider, and if we increase this 6, then it will be taller. And then with the SNS library, that is we imported earlier, that we use the heat map and correlation. Then with annotation we show the numbers. With line width you see the white divider, and FMT how we want to see the digits. So if we want to see it as a percentage, then we use 0.2%, then it will be percent, like how much they are correlated. And CMAP is actually the color of the heat map. So cool warm is, this is how it will show the cooler and warmer, like this. And PLT XT is just how the title will look like. So we run this, and in seconds we see how much they are correlated. So let's talk about what we see here. So what we see, temperature is the most positively correlated with the energy consumption, and relative humidity and the hourly sum of precipitation are the two highest negatively correlated features. And in addition, we see they are also internally correlated. So any one of these two features we can consider along with the energy consumption of the building. So let's see how it looks with the energy consumption. So let's easy way to see is to plot the energy consumption data against the relative humidity and the temperature. And for our convenience in visuality, we resample the data in a weekly basis. And to do it, we say the data frame and sum and weekly. So we bring the building column only, and then resample, and here with W we define weekly. We can also define it monthly basis if we replace W with M, and it is the main value that we are going to use. It can also be the sum in different other applications. And then for temperature and relative humidity, we resample, and later we do the plotting. So what is happening to plot? Well, you can just copy the entire code and paste in your code and run this, and this will give you this. But to understand what is happening is important in a way that you can actually modify according to your requirement. For example, at first we create the matplotlib figure, and in this figure this is the axis, and when we put the axis, what will be the x-axis? It is the index from this data frame which we defined earlier here, so that is the time frame. And for the y-axis is by default, if you see here, it can show you this is the which is what, and you can explore further from the library. So data frame sum weekly is the y-axis, and the color and marker is there, and similarly you can put the label of this x-axis and y-axis. Later we define a new axis in the x-axis, which is just duplicate for the x-axis, but it creates a new y-axis on the opposite side of the previous one, so that we can plot in the same figure two other features that we have defined here. So AX2 and AX3 we will use for the relative humidity and the temperature. Then later we use the legend is actually to show which is what, and when we run this to have the visualization, this line must be there to figure.show. And we see here that along the energy consumption is in red, and it's a weekly energy consumption. We see here that during the winter it is less, and during summer it is high, and again during winter it is less. So we can assume that it is some because of some cooling demand, as maybe in the tropical region, and also along with the energy demand, the temperature has a very positively correlated, and relative humidity is negatively correlated. So the energy consumption reduces, the relative humidity increases. Yeah, so it shows that the correlation is quite reasonable. So I end this video here. In the coming videos we will develop a prediction model, and we will see how we can predict and how we can improve the performance of the model to have a better accuracy. Thank you for your time.